Alright, we're recording. Alright, so today we are working on pages 389, 391, 389 to page 389 to 394 is what we're working on today. We're on session 3 of using a benchmark to compare fractions of lesson 19. Let's get the PowerPoint pulled up and let's go. Actually, I pressed the wrong thing there. Slideshow from current slide. Alright, let's go back. We get it pulled up, we get the right page anyways. Clicker in. So, our warm-up. Tell whether each comparison is true or false. The first one, 1/6 is greater than 5/6. True or false? Raise your hand if you think true. Raise your hand if you think false. Very good. 1/6 is less than 5/6, right? If I was to circle it, 1/6 would be right here. 5/6 is right here. Obviously, 5/6 is way more to the right, right?
Yeah.
So it's way more. 5/6 is way more. Then number 2. 2/6 is less than 4/6. True or false? Raise your hand if you say true. 2/6 is less than 4/6. Raise your hand if you say false. Well, so where is 2/6 at? 2/6 is right here, right? 4/6 is right here. Which one's further to the right? 4/6. So 4/6 is greater than 2/6, right?
Yeah.
So 2/6 is less than 4/6. That's pretty easy warm-up, wasn't it? So, I want you working on page 389. First question. Who wants to read it for me? Amelia, go ahead.
Wait, what is the name?
Jasmine.
Jasmine's swimming lesson lasts for 2/3 of an hour. It takes her 1/6 of an hour to do her homework. Does Jasmine spend more time on homework than or at her swimming lesson?
Alright, so Jasmine's swimming lesson lasts for 2/3 of an hour. It takes her 1/6 of an hour to do her homework. Does Jasmine spend more time on her homework or at her swimming lesson? So you guys have about, I'm going to give you 3 minutes to compare these two fractions. And I want you to tell me which one is greater, right? Where does she spend more time working on her homework or her swimming lessons? You guys got about 2 minutes. I'm not going to pause the videos for those of you that are working at home. You can just skip forward. If you want to pause it, you can pause it right now and you can skip forward to when we start working on it again, right? But we're going to keep it going for 2 minutes because Mr. Pathic's not that fancy with cameras yet. No? Good call. Alright, you have 1 more minute. Alright, so Normally, this is the time that we turn to a partner and talk. So what we're going to do today, though, is we're going to talk as a group, right? Because just so we can get the kids on the camera, we can get them into it as well, right? So, let me ask you guys, which strategy did you use to solve this problem? And how did you use it? Alright, Jacob, how did you solve it? You're going to have to talk kind of loud, right?
So I used the one model where you line them up like 1/6 on under it. You put 2/3 and so 6 is the bottom one on the 1/6. So you multiply 3 and 6 and 2 and 6, and that got me 12 and 18. And then 3 is the bottom one on 2/3. So I did 1 times 3 and 6 times 3, and that got me 3/18.
So you went and you found what? A...
Common denominator?
You found a common denominator, right? So Jake, he lined 1/6 here. He put 3, or not 3, 2/3 here. He does 6 times 3 equals 18. Since I did it to the bottom number, I must do it to the top number, right?
Yeah.
We gotta take care of the bunk bed. Top bunk gets the same as the bottom bunk. 1 times 3 is 3, so this 1/6 is what to 3/18? What is that word?
Equal.
Not equal. It is equal. What's the other word we use for equal? Equivalent. 1/6 is equivalent to 3/18, right? Because we did it to this, we do the same thing down here. Then he took 3 times 6 and got 18. 2 times 6 is 12. So 12/18 is now equivalent to 2/3, right? Are they easy to compare now?
Yeah.
Why are they easy to compare now? Michael?
Because they have a common denominator.
They have a common denominator. So now we're just comparing the numerators on it. So we look at the 3 and look at the 12. Which one's bigger, 3 or 12? 12? So 12/18 is bigger than 3/18. If these are equal, that means 2/3 is greater than 1/6. Does that make sense?
So she swims more than she does her homework.
Yes, absolutely. How else could you have done this problem? Nolan, talk loud for me.
I did 2 times 2 equals 4, and 3 times 2 equals 6, and then I compared 1/6 to 4/6.
Yeah, so Nolan did this. Did you have to do each one here?
No.
No, you didn't have to. Because we know that 3 can go into 6, right?
Yeah.
So do we have to change the 2/6?
No.
Or the 1/6? No, we don't. We can just do this. 3 times what equals 6?
2.
3 times 2 equals 6. Times the 3 by 2, what must we do to the 2?
Times it by 2.
Times it by 2. 2 times 2 is 4. Do we have a common denominator now?
Yeah.
1/6 and 4, they're both over 6, right? Now we compare 4/6 is greater than 1/6. So therefore 2/3 must be greater than 1/6. Anybody do anything different? Chris, what did you do?
I made a model. The top one was 2/3 and the bottom one was 1/6.
Alright, so Chris made a model. So he made a model like this. They have to be the same size, right? Why must they be the same size?
Because you can't.
Because you have to.
Because you can't do it. You can't compare them unless they're the same size.
You can't compare them until they have the same what?
Denominator.
Not same size. What do we call that size? What do we call it? Starts with a W? Not area.
Width.
No, not width. Huh? The whole, they have to have the same whole, right?
Yeah.
The whole has to be the same. W-H-O-L-E. So he divided the first one into thirds, right? Then he divides the other one into sixths. Now they're pretty close to the same. Which spaces are bigger, thirds or sixths? Thirds. Why?
Because you split it into a smaller number.
We're splitting it up less, right?
Yes.
We're only splitting this one into 3 groups versus splitting this one into 6, right? So now we just shade in 2 thirds. 1, 2. We shade in 1/6. Which one has more area? Which one has more shaded in? 2 thirds. Those are all ways that we can do this problem, aren't they? Those are all good ways to do it. Is there any questions on any of the ways we did it? If you have questions, ask them, because the kids at home might have the same questions and they can't necessarily ask them, can they? Yes, Jake?
So, on the one that Chris just did,
The models.
yeah, the models, can you go off, like, if you draw it again, like, and can you go off how many squares are left?
Nope, you go off of what?
How many are colored?
How many are shaded in? Because can I count squares and just go off of that?
No.
Why can't I do that? Does each fraction have the same size parts? No, so we can't just go off, well, this one has 3 parts, this one has 4. Right? You can't go off that. You have to go off of how much is shaded in, how much area is shaded in. So you could use a number line, believe it or not. The number line shows where the fraction 2 thirds and 1/6 are compared to 0 and 1. So we have 1/6 right here, right? They broke the whole. The whole is 1, right? So normally we stop at 1. 1 is the whole. Then we just break 1 into parts, right? This time, what do they break this whole into parts of? How much is the whole broken into? 6 pieces, right? 1, 2, 3, 4, 5, 6. The whole is broken up into 6 pieces. Then they just labeled where each fraction is on the number line. They put 1/6 here, right? There's 1 out of 6. They put 2 thirds here. Why did they pick 2 thirds there? This isn't broken into thirds. How can you put 2 thirds on a number line that isn't in thirds? Chris? Because 4/6 are equivalent to 2 thirds. Does that make sense? 3 can go into 6, can't it? How many times? Twice. So if I times 3 by 2, if I times 3 by 2, it turns into 6. Voila. Then I times 2 by 2 and get 4. Is 4/6 on this number line? Yeah, so I can put 2 thirds on that number line, right? Because it's equivalent to 4/6. I have a question. Now you just compare 2 thirds is right. If I had a number like this. No, I didn't want that one. Can I put that number line on that number, or put that fraction on that number line?
No.
Why not? Not a multiple. 4 is not a factor of 6, is it?
No.
Are any one of these lines equivalent to 1/4?
No.
I can't put that on there. So when is the only time you can use a number line when comparing 2 fractions? Amelia? When what is a factor?
When the number is a factor.
When the denominator is when one denominator is a factor of the other denominator, right? Does that make sense? Could I ever make a number line where 1/4 and 1/20th are both, or 1/6 are both on there?
Yes. No, actually. Yeah.
No.
How could you?
You can split it up into 8s.
Not 8s. Nolan?
12.
Yeah, what if I broke the number line into 12s? Could I put them both on there? Why?
4 and 6 are both multiples of 12.
Yeah, 4 and 6 are both factors of 12. So you could do it then, yeah. Both denominators have to be a factor of how much you broke the number line into. How many pieces are in the number line? Does that make sense? If they're not, are they going to be able to go on the number line? No. So the number line shows that 1/6 is closer to 0 than 2/3 is. It also shows that 2/3 is closer to 1 than 1/6 is. This means that 1/6 is less than 2/3, and 2/3 is greater than 1/6. Makes sense. Any questions? This is just one more way to compare them. Do you always have to use number lines? No, I'm not too concerned about that. Just as long as you know that there are lots of ways to compare fractions. Another way to compare fractions. Another way to compare fractions is by using a benchmark fraction. Use 1/2 as a benchmark to compare 1/6 and 2/3. So, on this number line, we have 1/6, right? We have 2/3. 1/2. Can 1/2 be on that number line? What's 1/2 when we're talking in parts of 6? Let's talk about it. Is 2 a factor of 6?
Yes.
Yeah, so can 1/2 go on there? Yes, it can. So they put 1/2 on this number line now. The number line shows that 1/6 is less than 1/2 and 2/3 is greater than 1/2. So we know that 1/6 is less than it, 2/3 is greater than it. So what does that mean? It must be, which one's got to be greater?
2/3.
2/3. If one's less than one number and one's more than one number, the one that's more than the number that we had, the benchmark, is obviously greater, right? 1/2 is a benchmark. We know where 1/2 is, right? Well, it doesn't go into everything. If I broke it into fifths, can I do 1/2? No, that's third. But if I know that one is, like, I just can sit here and think, okay, 2/3 is definitely bigger than 1/2. And I know 1/6 is less than 1/2. Can I just say right there, okay, 2/3 is greater than 1/6?
Actually,
Yeah. Okay, let's think of it like this. Say, okay, I have a benchmark of 5. I say that 3 is less than 5. And I say 7 is greater than 5. Do I instantly know that 7 is greater than 3? Just because 5 is in between them, one's greater, one's less than, right? Does that make sense now? Alright, let me do another one. Letter A, or number A, is less than 5. Number B is greater than 5. Which one's bigger? Number B, because it's greater than 5, right? That's what we're doing with this fraction. We're saying that one fraction is greater than 1/2. One fraction is less than 1/2. Which one's bigger? The one that's bigger than 1/2, right? It's common sense, right? Jasmine does spend more time swimming at her swimming lessons than she does on homework. Someone needs to get after Jasmine, make sure she's doing her homework. That was supposed to be funny. Do I need to get the applaud sign up here? Alright, thank you. Alright, which fraction 11/10 or 7/8? Which fraction 11/10 or 7/8 is greater than 1? Which one of those is greater than 1? 11/10 or 7/8? Raise your hand. Caden, which one's greater?
11/10.
How do you know that 11/10 is greater than 1? It's a fraction. It can't be greater than 1. How would we know 11/10 is greater than 1? Caden?
Because
The numerator.
is higher than the denominator.
Yeah, the numerator is bigger than the denominator. If I was to draw this out, right? Let's say we'll draw boxes because it's easier to draw boxes. And I had broken into 10. Broken into 10, and I shaded in them all. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I still have one left, don't I?
Yeah.
This is supposed to be 11. So I gotta draw another whole box
Just to fit one inside.
just to fit one inside. So is 11/10 greater than one whole? Because I shaded in one hole, and I still have one more, don't I?
Yep.
So 11/10 is greater. If the numerator is bigger than the denominator, it's greater than 1. Does that make sense? You guys learned that last year, didn't you? A little bit, maybe touched on it. Which fraction is less than one whole?
7/8.
7/8, right? Which fraction is greater? 11/10 or 7/8?
11/10.
How do you know?
Because if the numerator is bigger than,
Well, that's not how we know it's greater than 7/8. How do we know it's greater than 7/8?
because it has more boxes shaded.
We can't go out boxes, remember? How do I know? Not pieces.
Because the numerator,
Michael?
the area.
No, we didn't even draw 7/8. How do we know the area is bigger? How would I know? Carlos? Not because it's two whole things. What is it bigger than? What's 11/10 bigger than? Bigger than one whole. What is 7/8 less than? So if one's bigger than one whole, 11/10 is bigger than one whole, 7/8 is less than one whole. Doesn't that say that okay, 11/10 is bigger?
Yeah. It's because of the hole, right?
Are you comparing it to the one, right?
Yeah.
Because when both are compared to the one, I'm not writing this all out. You guys can listen to it. Because when 11/10 is compared to one whole, it is greater than one, right? When 7/8 is compared to one whole, it is less than, right?
Because when
So that means that 7/8 must be less than 11/10. Doesn't that make sense? Because when I compare both of them to one, one's bigger, one's smaller. So if 1 is greater than 7/8, doesn't that mean 11/10 must be greater than 1? Or being greater than 7/8? Does that make sense? That's called using a benchmark. 1 was our benchmark. A benchmark means like a mark that we know for a fact. We know for a fact 11/10 is greater than 1, right? We know for a fact 7/8 is smaller than 1. So if 1's bigger than 1, 1's smaller than 1, then the one that's bigger than 1 must be bigger than the one that's smaller than 1. That's a lot of 1s, isn't it? Yeah. You guys, I'm sure you guys understand it. It's a relatively simple idea.
did we have to write that all down?
No, you write it all down. You just get most of the record down. So now, write less than, greater than, or equal to show the comparison. What am I putting in that circle? Greater than. Right? Greater than is alligator mouth going to the left.
Yes.
11/10 is greater than 7/8. Explain how you can use a benchmark to compare fractions. We just said it, didn't we?
Yeah.
We're using the two things we know to compare two unknowns. We're using the known to compare two unknowns. Up to you guys.
Spell known now. I spelled known.
K-N-O-W-N.
Yeah.
Bless you. Any questions, comments, concerns? Number 6, reflecting it. We are going to skip that one for right now, right? Number 7, tell which fraction is greater, 4/8 or 3/4. Use the benchmark fractions 1/2 to explain your answer. Number 8, Nathan walks 10 on 10 of a mile. Sarah walks 11 on 12 of a mile. Who walks a greater distance? Explain. Use the benchmark number in your explanation. And number 9, use the benchmark fractions 1/2 to compare two fractions below. Which symbol correctly compares the fractions? That is all on your own, guys. I want you to do page 392, page 393, and page 394 on your own. Yeah, we are done. If you have any questions before you guys start on your own. Huh? Alright. You guys are on your own. We'll see. I will get another video posted tomorrow for the next lesson.
Wait, did you have a